Earth is the first and so far only place where humans can live, and many plan to venture to Mars or even the Moon. But that's expensive, dangerous, and would take years of work. So why should we go? How could we do it? And is it even worth it? All questions we'll be addressing in this episode of Impossibly Practical. Disclaimer, I am not a professional. All ideas suggested in this video are purely theoretical and made by a wannabe scientist with no qualifications. Don't take anything you learn as objective fact. This video and all others on this channel are made to entertain and inspire creativity. With that said, let's get into it. First, I think it's important to find the issues of this plan and solve them first. Then, I will show you these solutions in action in a concept Martian city, complete with exports, population estimates, and plans for its future. So to start, what are the core drawbacks to making a town on Mars? Well, for one, there's the solar radiation. Mars has no magnetic field and almost no atmosphere, which means the radiation is a real threat. But we can use reflective materials, lead-based shielding, or bury structures partly underground to protect from the radiation. There's also the lack of air, but we have spacesuits and space stations, so we have experience holding air in. The harder question is how to get the air. Mars has an atmosphere of nearly 95% CO2, so we can use that to create oxygen. But that's not all you need. To breathe, you need about 21% oxygen in one atmosphere, but it can be pure oxygen at 1/5 the pressure. However, this is dangerous as it is very flammable. Mars has ice in the ground, so you can use that for hydrogen, but that's even more flammable. I would use CO2, however it could be toxic in high concentrations, so that won't work either. Nitrogen is a good option, as that's what we use on Earth and even on the ISS. And there is nitrogen on Mars, but a whole lot less than there is on Earth. Only about 3%, and that's at a half atmosphere of pressure. So we're stuck. And that's when we turn to the same place humans have for years for when they don't have what they need where they are: importation. We could just import nitrogen from Earth. But until then, we should use a partial atmosphere of pure oxygen, or use a small bit of nitrogen in the Martian atmosphere. And of course, the spacesuits need this as well, as to not cause shock from the pressure difference. Now that we have air sorted, what about heat? It's very cold on Mars. Only reach about 70 or 80 degrees Fahrenheit at the highest. So we're obviously going to need to use some form of insulation. But we're also going to need some heaters. The heat should be even and disperse into the air easily. So I suggest not only using air heaters, but also something similar to heated floors or heated blankets. With heat-producing coils in the floors, it allows you to heat the ground, much like how the Earth stays warm. Most of the Earth's heat comes from the ground that is heated by the sun. That's also partially why high elevations are cold. This will allow you to naturally heat the floor, and only the air you need, the air you're in. Now that that's dealt with, it's time for the part you've all been waiting for: my Martian city. My city will primarily be a big air bubble. It will be a large, 2-layer inflatable dome. Inside it will be filled with air, and the in-between layer will be filled with insulation, likely some sort of hard foam to give it some structure. This 2-layer system also allows you to patch tears before they start to lose air. Inside will have underground coils, allowing you to heat the air naturally. It will also have air heaters and both real and artificial plants. Artificial plants serve a similar job to real plants but are much faster. They actually exist and are known as Moxie. The city will also contain many homes, at first for scientists and astronauts, but also civilians later on. The city will ideally only have about 100 people to start, as that's a good number for a solid workforce. But what would these people be doing? Well, mining for ice. Ice is water, but also important for spaceships. Hydrogen is so reactive that with oxygen as an oxidizer, you can create some of the most efficient rocket fuel possible. The city will export rocket fuel, along with various metals. You see, Martian soil is rich with iron, aluminum, and titanium, so there will be no shortage of metals. However, there may be a shortage of food, and that's a problem. We could obviously import food, but they would likely need to grow their own to keep up with demand. But if you have seen The Martian, you would know where this is going. We'll grow on plants. Plants need water, sunlight, air, but also select minerals, mostly calcium, sulfur, and magnesium. We have known there was magnesium in the soil of Mars for a while, but in 2011, we found both calcium and sulfur on Mars as well. So we have the building blocks. That means agriculture is coming to Mars. So now that we have food, water, air, shelter, all we need is power. Since we're mining for ice, we can use that hydrogen and oxygen to create power. It's so combustible that we can use it to generate tons of power by engines or similar generators. Now, what do we name this city? something symbolic and meaningful. Metis. In Greek mythology, Metis is the god of wisdom, born of the two water deities and first spouse of Zeus, the god of the sky. This shows how Metis is the first city of the sky, born of water, made of hydrogen and oxygen, aka rocket fuel, and its source of power. It's perfect. Side note, before I get roasted in the comments, I know it's pronounced Metis or Meaty. I just didn't look up how to pronounce it until now. So now we have a permanent population on Mars. What's the future look like? Where do we go from here? Well, here's the vision. Since Mars is a blank slate, it will allow us to fix many problems we have on Earth. We can create the infrastructure to be future-proof. For example, because there are no cars on Mars, we can make all of them self-driving. And they would have no need for cameras or radars, because we can make our roads specifically for self-driving cars, with sensors in the ground as invisible rails to follow. Currently, it takes 3 months to get to Mars. That's a long time. So how do we cut time off the trip? Lasers. We will make satellites with strong lasers on them to shoot at the ship. But how does this help? Solar sails. Solar sails are large and reflective, and they use light like wind to push a ship. Solar sails are slow, but in tandem with periodic boosts from the thrusters, we can definitely cut some time off the trip. Maybe even in half, but those improvements will take a while. So that's how I would make a Martian colony, and I think you'd agree that it'd be more than worth it. It would not only be almost fully self-contained with its own fuel, power, food, and water production, but also the core building blocks of all future Martian cities or solar civilizations. So with some solid work, enough thought, and good enough planning, even the hardest and most ambitious missions may turn out to be well worth it. That's all for this episode. Drop a comment if you got an idea for next week. I read them all. This episode took some work, so I hope you liked it. That's all I got. I hope you learned something, and I'll see you next week.